Yes, my name is Stefan Metzmacher. I'm a member of the Samba team. I'm working for SerNet, doing all kind of work based on related to Samba on behalf of our customers. And I'm talking about the effort to make use of iouring in Samba, and I presented about that before, and this is the status update where we currently are. So the topics are a brief overview of what is iouring, how we can use it in Samba, and what parts of it will be used in Samba, some performance research, prototyping and ideas, and then the heavy road to upstream and possible future improvements. So I gave presentations like this at SDC 2020 and 2021. If you're interested in some more details on older Samba versions, you may want to refer to these. For now, I'm starting with what is iouring. It's a new scalable async I/O or async syscall interface in Linux, which was introduced with the 5.1 kernel, and it's designed to avoid syscalls as much as possible. So you basically have a shared submission ring and a completion queue ring shared between user space and kernel, and the user space submits new entries to the submission queue and will eventually get a completion in the completion queue when the request is ready. There's an detailed explanation on that on a lwn.net article. If you have the slide, you can click on that link. Yeah, this nicely integrates with our T-event async model, where we have a request submitted and then wait to the result to come back. And so far it looks like the overhead, even if they create kernel threads, is much less than using user space thread pools and something like this. And in some situations it's also possible that the kernel will not spawn any threads at all and do inline non-blocking operations, which is good for latency. So in Samba we can use what we already do is using it between user space and file system interaction. We have a VFS module for that, and there we can use the readv, writev, fsync operations, and in later kernels we got support for fsetexutter, fgetexutter. There are discussions about getDends and effortwise, but these are currently not used in Samba, but we could possibly do that in future. There are path-based syscalls which allow async impersonation. So in Samba we have often the problem that we need to do some calls to say become user X in order to open a file and get the permission checks on behalf of that user. And with iouring you can do something like an operation to capture the iouring register personality call, which captures the current permissions of the process and gives that a number, so that future iouring calls can refer to that and can then easily switch between operations and between personalities. And yeah, this would be useful for calls like open add, statex, and so on, which are partly or completely path-based in order to get the permission checks correct in the async nature of the requests. And in theory, we could also remove all the impersonation we do by default for each operation in Samba, which is adds quite some complexity and overhead to operation processing. And with that, we may defer that to the VFS modules and only do it when strictly needed. And in the iouring case, it wouldn't be needed at all. Then we have the case between user space and the socket. And for that, we would use the send message and receive message operations via iouring. There are some more details which partly I added to the kernel, where we have special handling for message wait all in order to get fewer wake ups. And if we want to wait for, let's say, 1K of data, then we specify that flag, and we will only be notified when this 1K of data is really available in the socket, and don't get wake ups for partial packets, which is important in order to avoid additional syscalls and latency. There is a flag called iosque async, which forces processing in a helper thread, and we may decide to use that because for large I/O, the memcopy operation blocks the process, and we may want to defer that memcopy into threads in order to be able to process more requests in the main thread. Then we have splice and T, which could be used for some zero copy stuff. I will explain that in more detail later. And then just recently we got a send message zero copy function, which gets two completions: one when the logical send message operation is ready, and another one when the network stack no longer needs the use pages and data buffers. So then we can reuse the memory. There's also a discussion about an iouring get buff operation, which could replace the splice call, but that is something that's still under discussion, and I'm not sure if that ends up in the kernel or whatever happens there. So with Samba 4.12 in 2020, we already got the iouring VFS module, as I said, and that brings a little bit of performance boost, but not all. That's possible, but it might be better than have nothing. So I was able to get from 2.2 gigabytes to 2.7. Yeah, and as I said, the improvement is mostly by avoiding context switches, and the memory copying is still being done. Then I did some research with a few systems which had 100 gigabyte Ethernet cards, and I was able to demonstrate or prototype some iouring work there in order to get better performance. At that time we used the 5.8 kernel, but the same applies to newer versions as well. And yeah, more verbose details can be found at that URL. If you have the slides later, you can click on it. So the first is, we had a Windows client using the FIO benchmark in order to test what's possible without any tuning and just to see where we are at the moment, which means we are using the send message call as normal system call, and then we have a thread pool that does the IO operations in the VFS, and with that we got over 4 connections using multi-channel just 3.8 gigabytes per second, and we used more than 500% CPUs in total, and the send message operations take up to half a millisecond, which is the main constraint where we are just blocking in memcopy, blocking the process from doing useful work. Then I prototyped the iouring based send message call, which means that we deferred the memcopy into helper threads, and with that we got from 3.8 to 6.8 gigabytes per second, and the CPU utilization was dropped to about 300%. So it's already a major improvement. It's not completely great, but much better as before. And yeah, we still see in the perf top output that memcopy, so this is a copy user enhanced file string operation here. This is the low level one for memcopy in the kernel. That is still the major bottleneck there. Then I prototyped send message followed by splice, where we have splice from the file to a pipe and then from the pipe to the socket, which means we have basically 0 copy. And with that we were able to get 8.9 gigabytes per second, and CPU utilization was down to just 100%, so just one CPU core was fully utilized. Yeah, and it turned out that the Windows client is still the bottleneck here, even if using 16 connections with multi-channel. Then I did the same with a modified SMB client, where I was able to get with 4 connections just, and then 11 gigabytes per second, which is almost network speed, and the CPUs are basically down to 20% on the server. Then I redid that using Loopback with 8 connections, and that got basically 22 gigabytes per second, which is basically the maximum of the loopback speed that's possible. And still their SMB client is a bottleneck there. So later I redid the tests, maybe skip over that a bit. So basically we get similar results, just with better numbers because we had better hardware. And I also implemented the other side, the receive message with splice. So basically that SMB write calls would use 0 copy, or as it turns out it's just one single copy. And I also got very good results with that. And yeah, in both cases SMB client is clearly the problem, and the 0 copy support from file system to pipe and to socket is much better optimized than the other way around. So in order to get this prototype into something that is able to get into Samba master, I need to do some prerequisite work, And I think it was about 12 years ago or so, we discussed on the mailing list with someone that we would like to have a t-event fd error flag. So currently we have just read and write, and only if you ask for readability on the file descriptor, you will also get notified about errors on the socket. In order to split that, we thought about implementing the fd error flag, and with the iouring work I finally found the reason to really do it, and I have patches to implement that, so that with iouring send and receive message we still be able to use the main t-event code in order to detect errors and tear down the connections as fast as possible. There are some merge requests listed here, and also an additional merge request that converts parts of Samba to make use of it. It also simplifies a lot of code not related to iouring, where we had special hacks in order to get notifies for errors when we just want to write something. Then the next idea is to have an Samba iouring abstraction, which is able to allow us to have more or less if-def-less code in Samba. So we will have an event register function that checks in the system, is iouring available at all? If so, it registers t-event backend, and then we have functions to get iouring features, the global one, and then have a function to get an Samba iouring context based on any given event context that may return null if there's no iouring context attached to it, and then the code can just check, okay, in that case I need to fall back to legacy code. So, and yeah, the caller will just use the Samba iouring event context. This is basically factoring out some common code from the VFS iouring backend, and it means that we will basically be able to use iouring everywhere where we have a t-event context. And yeah, as said, no if-defs, we just check the features which are available on the current system and react on that in order to do fallbacks. So in order to work with this, we have two types: a completion abstraction, a submission abstraction, and these are filled with callback functions. The completion function is called when the completion arrives. The submission function is there to notify when we submit the request to the kernel. So we below we have the queue submission function, which queues the request, the submission, into the queue, and requests may sit there for a while, and in order to debug latency in the queue, we will have the submission function, which is exactly called before we hand over to the kernel. And of course, for the submission, we are able to get the native iouring SQE structure for the submission. This is defined in the kernel, and there we can set up the operations in order to pass them to the kernel later. And yeah, this is used in VFS iouring Samba, where I converted to the new abstraction, and then I have code to use it in the SMB2 server, and later we are hopefully able to use it in other critical places too, like SMB client or something like that, where performance really matters. So in the SMB2 server, the first step is to have optional support for send message and receive message. Everything else still behaves like before. We just don't use the send message and receive message syscalls anymore. And yeah, as seen in the pictures before, this is able to defer memcopy load to helper threads if there's a workload where a lot of large IOs is happening. Then I analyzed the send message splice approach a bit more, wrote a little test in order to find out how splice really works, and started a discussion with the Linux developers, and it seems that, or what I found in my test is that when a page from the page cache of a file gets written to, then that affects the page that might be still in the output queue of the network layer and modifies data there. So this is not really great for us, and basically it's the same as with our current send file option we have, but at least it's good to know that there might be problems, and we need to decide if we still want to enable that because of the great performance, and maybe there aren't any real problems. Maybe some OEMs also have the send file patches activated for a long time and nothing bad happens, but I guess it shouldn't be the default at least. But the good thing is that for the receive message side there shouldn't be such problems, because once we get the pages from the network layer, we are sure we are the only owner of that pages, and then we can make sure that they are not modified on the way to the file system. So with the new send message zero copy operation in iouring, we can get away with just one copy instead of two, which means that we could at least have some better performance than the current state. And yeah, basically we can avoid the memcopy in the network layer there. I don't have real numbers here because it doesn't work on Loopback interfaces, because that would mean the same problems where the sender and the receiver would still share the pages, and if the sender later modifies them, the receiver would get modified data, and that's the reason why the Loopback code doesn't do the zero copy stuff. It's possible to hack that in the kernel and do some experiments with that, but with the default kernel it's not possible. So I tested with virtual machines, and there I can see improvement, but that's nothing that has stable results as in almost any case where VMs are used for performance work. So for the future, I also prototyped a native iouring event backend where we would not use epool as blocking call into the kernel, but instead we would use the iouring enter syscall as only blocking code call into the kernel. And with the lipiouring built around that, it's certainly possible that some operations don't need to enter the kernel at all and get improvements there. But the sad thing is that the poll add and poll remove semantics of iouring are not really useful for us, because they get an additional reference on the socket, on the file descriptor of the socket, and that means when our main code calls close, the connection is not teared down, so it's kept open, and that caused problems with tests. And I proposed some changes for that, and have patches for that. But as there are also other problems with level triggering and so on, I deferred these and worked with the ePOL backend for now. So yeah, I said before, as we have the t-event context everywhere in the whole stack, we might use iouring in the SMB client code as well in order to speed up operations there. And yeah, that's basically for my talk. I can also say that bringing all this stuff upstream or preparing for upstream is a bit hard, because I try to not introduce performance regressions, of course, and for each single patch I basically do some benchmarking and so on, and sometimes it's possible to rewrite things and still improve things in other places in order to get faster instead of slower, because all this has the aim to get faster. Okay, so any questions about that?